Okay, this is section 7.1c, and this is going to be where we put all of the rules from the first two sections into practice. I'm going to remind you that we learned how to uncancel and unswitch, and if you're not familiar with how to do this, you need to go back to section 7.1b. So we're going to uncancel and unswitch our charges, and then we're going to identify the name of our compound. So here we go. First example is CuCl2. First, I need to make my dividing line. This is a 1:2 ratio, which unswitches to give copper a +2 and the chloride a -1. So the name of this is going to be copper 2, and the name of my anion, which is Cl-1, will be chloride. My second example is going to be NH4 it's in parentheses with a 3. That means I have 3 of this polyatomic ion in the parentheses, and I only have 1 of this other polyatomic anion. So we have a 3:1 ratio. NH4, we're unswitching, so that gives NH4 a +1 charge and PO4 a -3 charge. So NH4 +1 is called ammonium. I have 3 ammoniums, as it were, and PO4 with a -3 charge is called phosphate, and I have only 1 phosphate. My third example is Al2O3. If I unswitch these charges, I have a 2:3 ratio, which gives my aluminum a +3 charge and my oxygen a -2 charge. So Al +3 is known as aluminum, and O-2 is known as oxide, and those are both on your periodic table. CO2 is very tricky. There is no dividing line here. This compound is not ionic, and I know that because it's a nonmetal plus another nonmetal. Remember, you can only do these rules if it's an ionic compound. So if it's not ionic, it's going to have different naming rules. This one is covalent, and we will learn the naming rules for a covalent compound in section 7.2. My next example is COP, cobalt and phosphide. And notice I have a 1:1 ratio in this case, so I'm going to have to uncancel. Cobalt is a transition metal, so I can't tell what the charge is using the periodic table. I'm going to have to identify what the charge of phosphide is. And notice on your periodic table, phosphide is in the -3 column, giving it a charge of -3. Therefore, the cobalt must be a +3. So CO +3 is called cobalt, Roman numeral 3, and P -3 is phosphide. You can see where you need a good understanding of your ions in order to make this an easier process. Our last example, I have 2 lithiums and I have 1 of this polyatomic ion, which is called hydrogen phosphate. I'm going to unswitch. My ratio is 2:1, which gives lithium a charge of +1 and hydrogen phosphate a charge of -2. So Li +1 is lithium, and HPO4 -2 has 2 names. You can either call it hydrogen phosphate, or that could be shortened and we could call that biphosphate. Both names would be acceptable on the test. So let's kind of mix it up. If I give you the name, you should be able to give me the formula, and given the formula, you should be able to give me the name. So if you'd like to pause the video now, you can try these out on your own and then come back to get the answers. Zinc is +2, acetate is C2H3O2 with a -1, which makes this a 1 zinc to 2 acetate ratio. Copper 1 is Cu +1. Nitride is on the periodic table N-3. If I switch the charges, I have a 3 copper to 1 nitride ratio. Magnesium is +2, carbonate is CO3 -2. These are going to cancel, giving me a 1 magnesium to 1 carbonate ratio. Aluminum is +3, hydroxide is OH -1. These are going to switch, giving me 1 aluminum to 3 hydroxide ratio. Notice hydroxide must go in parentheses because it is a polyatomic ion. It has to stay together like a bundle. And then my last one here is iron 3, phosphite is PO3 -3. These are going to cancel, giving me 1 iron to 1 phosphite ratio. On the right hand side, I'm going to need to unswitch or uncancel first. Here's my dividing line because I know what my ions are. So NH4, C2H3, this is a 1-to-1 ratio. I'm just going to have to know that ammonium is +1 and that acetate is a -1. So the name of this is ammonium acetate. Okay, here's my dividing line. This one was switched because it's a 1-to-2 ratio. So that gives this a charge of +2, that's a charge of -1. That is cobalt to chloride. Here's my dividing line. I have a 1-to-1 ratio. I can look at the periodic table to know potassium is +1, which means this must be a -1. So I have potassium, and if you look at your ions list, MnO4 with a -1 charge is called permanganate. Not to be confused with manganate, which has a -2 charge. Sr and S, this has a canceling, so we have a 1-to-1 ratio, and you can look at the periodic table for both of these. Strontium is +2, sulfide is -2, making this strontium sulfide. Last one, we have the dividing line. We have 1-to-2 ratio, which makes this a +2 and this polyatomic a -1. So that gives me a copper 2 and ClO3 -1 on your list of ions is called chlorate. Please be aware that on our final answer, such as on the left-hand side, there are no charges present, and there shouldn't be. Charges are understood. Does that mean the charge is still there? Yes, as you see on the right, we can figure out what the charges are, but we don't write them because it's supposed to be understood or known, or you should be able to figure it out using the ratio. In our next section, 7.2, we're going to look at how to write the formulas and how to name covalent or molecular compounds.